Graph the quadratic function, label the vertex and axis of symmetry. So here, A is 1, B is 2, C is 3. Starting with that axis of symmetry, x equals negative b over 2a. So that makes x equal to negative 1 as our axis of symmetry. So I'm going to draw that vertical line here. X equals negative 1. Now remember, our vertex is going to fall on that axis of symmetry, so we know the x value is negative 1. The y value is negative 1 squared plus 2 times negative 1 plus 3. So that's 1 minus 2 plus 3, or negative 1 plus 3, y equals 2. So negative 1, 2 is our vertex. So now we need to find the y-intercept. That's when x is 0. So y equals 0 squared plus 2 times 0 plus 3, or y equals 3, is here on the y-axis. So now I want to reflect the y-intercept across the axis of symmetry. So since this y-intercept is 1 away from that axis of symmetry, I'm going to go 1 across to create that symmetrical sister point. So now I need to try to find my x-intercepts. So 0 equals x squared plus 2x plus 3. So remember, if I checked a times c, that's 3. And I'm looking for two numbers that multiply to make 3 and add to make 2. That is not possible to factor. Now I can check with my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that makes x equal to negative 2 plus or minus the square root of 4 minus 12 is negative 8 all over 2. So notice here our discriminant is less than 0. So that means there's no solution. So we see whether we try to factor or use the quadratic formula, there's no solution. Therefore, there are no x-intercepts for this problem, which can happen. So notice, if I look up here and I just connect these 3 points that we have, our parabola has to open upward like this, and you can see it will never cross the x-intercept. Therefore, there are no x-intercepts.